Genique? So this is the question asked on the end fire array. So if you observe this, in a uniform linear array, 4 isotropic radiating elements are spaced lambda by 4 apart. The progressive phase shift between the elements required for forming the main lobe at 60 degrees of the end fire. So here he has asked for the end fire array and the spacing lambda by 4 is given, and how many elements? There are 4 elements are given. 4 isotropic radiating elements are spaced apart lambda by 4. The progressive phase shift between the elements required for forming the main lobe at 60 degrees of the end fire is, the question is dash. So this is the option. What we have to find? We have to find the progressive phase shift, means we have to find alpha. And what he has given? So in this question he has given D is equals to lambda by 4. The distance between the two elements is lambda by 4 is given. And he has given 60 degrees. What is this 60 degrees? And n is equals to 4 is given. We know the error factor. The error factor is equals to what? The error factor is equals to sine of n psi by 2 divided by n into psi by 2. This is also called as normalized error factor. So before going to this solution, observe this. What would be the end fire array? So how the end fire array would be? There are 4 elements. Let us suppose there are 4 elements are there. Okay. The 4 elements are placed like this. The 4 elements are placed like this. Observe this. 4 elements, 1, 2, 3, 1, 2, 3, 4 elements are there. These 4 elements are placed like this, and due to this, the end fire array, see, this is the axis. This is the axis. Okay, so this is the antenna axis. So how the we got already. How would be the what is that called? The broadside array. The broadside array will be having the radiation pattern in this direction, right? But here the end fire array will be having the radiation pattern in this direction, right? So this is the radiation pattern of this end fire array. What would be the broadside array? The broadside array would be having the radiation pattern in this direction. Suppose this is 1 element, 2, 3, 4. 4 elements are there. This is the radiation pattern for the, it is right angle to the, it is right angle. This is the axis. Let us suppose this is the Z. In this, these are 4 elements are placed. Okay. The broadside array direction will be this one. Okay. Don't think that in the previous case we have taken like this. But the axis is like this. So that's why we have taken like this. Okay, so that is the thing. Here I have taken this, or otherwise to avoid you can also take this. You can also take in this direction. The end fire array will be like this. Okay, so the end fire array radiation pattern will be like this. Okay, so now this is the end fire. This one. Let us suppose the same arrangement is given like this. The same arrangement is given like this. Okay. So that means it is the Z axis, the first element, second element, third element, fourth element. Okay. How the radiation pattern will be? The radiation pattern will be in this direction or upward direction. The radiation pattern will be in this direction. Okay, so this is the radiation pattern, or it can also be in that direction. So like this. So now if you observe this, what is the theta is given? Here it is given 60 degrees of the end fire array. So here it is, observe this question, in the uniform linear array, 4 isotropic element spaced at how much distance? It is lambda by 4, lambda by 4, lambda by 4. Okay, so see, observe this is the radiation pattern. It is better to write the radiation pattern in this direction. Okay, it is the end fire array direction. Okay, it is the end fire array direction. Now if you observe this is D is equals to lambda by 4, D is equals to lambda by 4, D is equals to lambda by 4. Okay, so now what he has asked, the phase shift alpha you have to find for forming the main lobe. The main lobe is nothing but what? The maximum point. For finding the maximum. For finding the maximum, what should be the psi? For finding the maximum value, what should be the AFN? The normalized error factor. It must be 1. So for finding 1, where you will get 1? Here you will get 1 when psi is equals to 0. If you write the L-hospital rule or something, okay, if for finding the, suppose if you put n equals to 4 here, n equals to 4 means it will be sin psi divided by, here sin 2 psi divided by, suppose if you put n is equals to 4 here sin 2 psi divided by 2 into sin psi by 2. Okay, so here to find if psi is equals to 0, it will get a maximum value. Okay, for sin psi is equals to 0, psi equals to 0, you will get a maximum value. Or otherwise you can also write L-hospital rule. If you put psi equals to 0, you will get 0 by 0. If you take the what? L-hospital rule, you will get the maximum value. So no need to do this one also. Okay, so that means you have to notice that psi, it will give a maximum value for psi equals to 0. For psi equals to 0, for psi, what is psi here? The psi here is equals to alpha plus beta d cos theta. Here all these diagrams are not required. Okay, but one thing you have to note, that is what? Here it is making an angle. The main lobe, see, this is the end fire array radiation. But here it is making an angle. What? The radiation is in this direction. He is saying like this. So that means it is making an angle of theta is equals to 60 degrees when compared to this. This is what the meaning of this question. Okay, it is making an angle. See, find the progressive phase shift between the elements required for forming the main lobe at 60 degrees of the end fire array. 60 degrees of the end fire array. It is end fire array direction, but 60 degrees of the end fire array. So this is 6. Or otherwise you can also take in this direction. You can also take 60 degrees in this direction also. So that means he has given theta is equals to 60 degrees and psi is given. Sir, for maximum, what we have done? For maximum radiation or for forming the main lobe, okay, for forming the main lobe, the psi must be is equals to 0. If it is 0, it will be alpha plus 2 pi by lambda into d is, what is the d? D is already given. It is lambda by 4. Here d is given. D is lambda by 4 is given. So here it will be simplified. This is cos 60 degrees. So here alpha can be is equals to minus, this is pi by 2 This is minus pi by 2. 2 pi by 4 is minus pi by 2. Cos 60. Cos 60 is 1 by 2. This is minus pi by 4. Alpha equals to minus pi by 4 radians. So the question is not needed actually. The figure is not needed actually. Okay. So this is the thing. So you have to notice this. What he has given? Theta is given. And spacing is given. You have to find alpha, and one more thing is given, that maximum lobe is given at where? 60 degrees. If it is not given means always it will be in this direction. Theta equals to 0 direction. Okay. So that is what the question. Welcome to Genique. This is our next question. Two identical and parallel dipole antennas are kept at a part by a distance of lambda by 4 in the H plane. They are fed with equal currents, but the rightmost antenna has a phase shift of plus 90 degrees. The radiation pattern is given as. So if you observe the question, so in this question what he has asked means, it is given in the, the two elements are arranged in the what? H plane. H plane means it is XY plane. You have to note that. H plane means it is XY plane. XY plane means what? It is X, it is Y. It is X, Y. X, Y. It is placed like this. It is X and Y. That means how the antennas are kept. It is kept like this. Antennas are kept like this. Means this is one element, another element, okay, with equal currents. This is I0, this is I0 e power j 90 degrees. This is the thing he has given. First element and second element are having rightmost is given as plus 90 degrees. Okay. Now that means what? What is alpha? Alpha is equals to the phase difference between this one and this one. It is 90 degrees. Alpha is given. And we have to identify the radiation pattern. Two elements are there. For these two elements, let us suppose this is what? X. And what about this? This will be Y. How these are kept? These are kept like this on the horizontal plane. Means they are kept like this. Okay. So it is the direction where we have to find the far field point, far field pattern. Okay. Let us suppose this is the theta and this is the theta. This is the theta value. Okay. So this is the theta, because from this line to, from this horizontal axis, this is the axis. So theta is always calculated as what? From the theta is always calculated from the axis to the field point direction. Okay. So it is the axis, it is the field point direction. This is the theta. So in this, if you observe this, what is psi? Psi equals to alpha plus beta d cos theta. What is alpha? Alpha is given, it is pi by 2, pi by 4. Alpha is given, it is pi by 2. It is pi by 2 plus, what is beta? Beta is equals to 2 pi by lambda into d equals to what? D is how much distance they are kept? They are kept, d is equals to how much? Lambda by 4. Okay. They are lambda by 4. So now this is lambda by 4 cos theta. Lambda will get cancelled. Here you will get pi by 2 into 1 plus pi by 2, 1 plus pi by 2 cos theta. So this is the thing. This is psi. Now what is the error factor? Why we have to find the error factor? Error factor is deciding the radiation pattern. So that's why this is cos of psi by 2 is the error factor. So what is cos of psi by 2? This is mod cos of psi by 2. Okay. So this is deciding the error factor. This is for what? This is for n is equals to 2 element array. Okay. So this will be equals to cos of, it is psi is what? It is pi by 4. It is pi by 4. Here 1 plus cos theta. So this is the final error factor. Now observe this. This entire now is a pi by, this is one angle. So if you observe this is representing what? This angle is representing theta equals to 0. If it is in this direction, theta 0, it is means theta is some non-zero value like this. So suppose if you put theta equals to 0, if you put theta equals to 0, if you put theta equals to 0 means what? It is 0, 1 means 1 plus 1, this is 2, cos pi by 2. So error factor will be 0 if what? Theta equals to 0. If theta is equals to pi, what happens the error factor? The error factor will be is equals to, the error factor will be, this is cos theta, cos pi is minus 1, it will be 0. So cos of 0 is 1. So for theta degrees, it is having a maximum, it is 0 radiation. For theta equals to pi, it is 1. See, if you observe this first figure, for theta 0, it is 0, but for theta pi, it is 1. So you can, it is a wrong option. Wrong option. What about this? Come to this. If you come to this, theta equals to 0 degrees, in theta equals to 0 degrees, there is AF is 0, but it is not 0, it is having some value. Okay, it is having some value in this direction. Okay, but it is also this one. But here, what is this? These are the error factors. This is representing error factor of magnitude. But if you observe this, AF equals to 0 in the theta direction, means in the theta direction, theta equals to 0, it is 0. Theta equals to pi, in this direction, there is a non-zero value. So this is, understand? It is a non-zero value. Okay? At theta equals to 0, it is having 0. But here at theta equals to minus pi, it is having a non-zero value. So this is option is satisfying. Now if you come to this, one more option, here it is having a non-zero value, it is having a non-zero value. This is also not right. So answer is this one, option C. So have you done anything new here? Nothing. Just we have taken the data and we have found the sigma, this psi value. After that we found the error factor. By putting the theta values 0 and pi, we checked this. And there is also one more method, okay, for which we have taken the unit pattern and the error factor. You have to multiply that. Unit pattern and the error factor, for that we have to multiply. Okay. So like that also you can calculate the radiation pattern for this. Okay. Thank you. Welcome to Genique. It is a question asked in the gate examination. A lambda by 2 dipole is kept horizontal at a height of lambda naught by 2 above a perfectly conducting infinite ground plane. The radiation pattern in the plane of dipole E plane looks approximately. Here E plane is nothing but it is placed vertically. So what he has given, there is a perfectly grounded plane is there. Okay, here E plane is means what? Vertically placed. They are placed vertically. Okay, they are placed vertically. So if you observe this, there is a perfect ground plane is there. So on this, on the vertical axis, the lambda by 2 dipole is kept. Let us suppose this is the vertical axis. Let us suppose this is the z axis, also called as antenna axis. It is antenna axis because he has given it is placed on the vertical axis. Okay, so one dipole is kept horizontally at a distance of how much? Lambda naught by 2. The distance from here to here is lambda naught by 2. Now you have to find the radiation pattern in the plane of dipole. So we have to find the radiation pattern for this. How can we find the radiation pattern? If you observe it clearly, so one element is placed near to the conducting plane. When there is a conducting plane here, so there exists, we have to remember one thing, we have to recollect one thing, that is, if any element, a current element or any charge element is placed near to the conducting surface, there exists an image is produced at the same distance. Okay, so that is the thing you have to notice, because it is a conducting infinite sheet, it is a conducting infinite plane, so there at the same distance you will get the same kind of current element. So here you got what? Here there existing one dipole. So here in this ground plane, in this near to this conducting surface, there exists one more current element like this. This is already existing. We put this of how much current? The current is, let us suppose, I0. Okay. Now how much current will be producing here? Here also I0. But if you place a C, according to the image charges, if you place any point charge plus Q at the distance of D, the same minus Q will be induced at the same distance. So that is the thing you have to notice. So minus Q will be induced because of this conducting surface. Similarly, if you put any antenna here near to the conducting plane, automatically at the same distance, the same current, same amount of current will be produced, but it produces a phase difference of 180 degrees. So here it will produce a phase difference of e power how much? E naught, I naught into e power plus j pi or minus j pi, plus or minus j pi. So this is the phase difference. So indirectly he has given it is pi. Indirectly he has given that it is pi. Okay. Now what is the distance between here then? What will be the distance here? At the same distance the image will be produced, right? So here also what is the distance? Here the distance would be lambda naught by 2. Okay. So this is the arrangement we made it. But because of this placement of this current carrying element, because of we are placing this current element can also be known as what? Antenna. Okay, because of this antenna placed here near to this current conducting surface, image current element will be produced here at the same distance. It is induced current element. So alpha is pi because there exists a negative charge here. Okay. Now what happens? If current is I, means it is minus I naught. So that is the thing. So that means this is what? This is I naught. What about this? This is minus I naught. The meaning of this one is this. Understand? So now alpha is there. What is beta? Beta is equals to. So now what is psi? D equals to what? The distance between these two. Now they are looking like what? Now they are looking like two conducting surfaces. The two current elements placed at a distance D. Okay. So now this is D. So D is equals to what? Lambda by 2. It is lambda. Okay. Lambda by 2. It is lambda. So now what is psi? Psi equals to alpha plus beta D cos theta. So this is equals to alpha is pi plus beta is 2 pi by lambda. What is D? D equals lambda. lambda or lambda naught, whatever. If it is lambda naught, it is also lambda naught. Okay. Cos theta. So this will be lambda gets cancelled. Pi into 1 plus 2 cos theta. Okay. So now instead of writing this, now what will be the error factor? Error factor is equals to, for 2 element, cos psi by 2. See, in this question, it is only one element is given, but it is placed at the conducting surfaces. So it became a 2 element now. Okay, because of this induction. So now, so this is the thing. So this is cos of, if you take, this is equals to what? Pi plus 2 pi cos theta. So this will be pi by 2 plus pi cos theta. Okay. So pi plus pi by 2 plus pi cos theta. Now observe this. If you observe this, what happens? If theta equals to, or you can also write sine of, this is what? It can cos 90 plus theta. Cos 90 plus theta is, here AF is equals to what? AF is equals to mod of minus sine theta. Cos of 90 plus theta. So minus sine theta. So you can also write, because of mod, sine pi cos theta. So this is the AF. Sine of pi cos theta. Suppose if you put theta equals to 0. So suppose if you put theta is equals to 0. Okay. So what is the theta now? The theta is this one. The theta is this one. This is theta now, because the theta made by the angle, this line, the theta made by this angle, radiating wave with respect to the axis. Okay. So always the theta is measured from the axis to the far field point. So suppose if theta equals to 0, if theta is equals to 0 degrees, what happens? AF is equals to, this will be what? If theta 0, this is 1, so sine pi is 0. If theta is equals to, if theta equals to pi, what happens? If theta is equals to pi, what happens? This will be, AF will be, if theta equals to pi, this cos pi is minus 1, minus pi, it is also 0 now. Okay. Now, if theta equals to pi by 2, if theta equals to pi by 2, what happens? Theta equals to pi by 2, it will be what? It is 0. 0 into sine 0, and theta equals to pi by 2 also, AF is equals to 0. Okay. So if you clearly observe this, so observe this, if theta equals to 0, AF is 0, and theta equals to, this is what? This is theta equals to 0 representing. It is theta equals to 0. It is theta equals to 0. It is theta equals to 0. So you have to notice theta. What is theta? Theta is always from the antenna axis. The antenna axis can be, this is what? This is called as antenna axis. Okay. This is called as the antenna axis. It is always measured from the antenna axis to the field point. So now this is the theta. So depending on the orientation of the axis, the theta will be sometimes taken from the horizontal axis. Suppose if it is in H plane, if it is H plane, we have to take the theta from horizontal axis. Suppose if it is vertical plane, E plane, the theta will be from vertical axis. So that is the thing. So this is theta now. So if you observe this, in the theta equals to 0 direction, AF is 0. So we can remove this. Maybe chance. In theta equals 0 degrees, AF is a 0 means there is a chance. What about this? You can remove this. What about this? There is a chance. Now come to the second one. Theta equals to pi direction, AF is 0. What is pi? This one. So there is no radiation. So there is a chance. Now come to this. Theta equals to pi direction. Theta equals to pi direction. there is 0. There is a chance for this also. But come to this, theta equals to pi by 2 means what? This is theta equals to pi by 2. In this pi by 2, it is not a 0 value. So you can remove this. So this will be the option. So for any question like this, till now we have solved 3 to 4 questions. So on all these questions, we have find the error factor. So for finding error factor, already we are having this expression. Okay, if it is a 2 element, directly you can write cos psi by 2. So for finding psi, already we have obtained the phase difference expression every time. Okay, so like this, you have to, so after finding this psi, and you have to find the error factor. So in that error factor, and finding the theta is also a challenge. So how to find challenge? Suppose if the horizontal axis is given, okay, suppose if the antenna axis is horizontally given, means H plane is given. So the theta will be measured from the horizontal axis. Suppose if the theta is in the E plane, if the antennas are placed in the E plane, means vertically placed, then theta will be measured from the vertical axis. If the antennas are placed in the horizontal plane, then the theta will be placed from this. If the antennas are placed on the vertical axis, then the theta is measured from this. That is the thing you have to notice. If you don't know that, you may get confused. Understand? So like this, you have to answer this question. So for finding, see, for finding answer for this question, it is not less than, it is not more than 2 to maximum 2 minutes. Suppose if you don't know the concept also, if you follow this, okay, 2 minutes is very high. But if you don't know this concept, so but if you follow that another method, some traditional method, it will take more time. But if you know this concept, maximum 1 hour, 1 minute, it will be completed. Okay, I hope you got this. Thank you.